because they are coming non-obstructive, difficult, very easily, and much more difficult. In our proposal, we have our group are assigned to make a new product with the aid of semi software, and we have choose four products which include which are the connecting rod, NPT plug, hand holder, and a fidget spinner. After considering our discussions and lecture suggestions, connecting rods are chosen as the product that will be made in this group. In this figure, the list of tools are selected, are shown in below, and, and the tools are mainly in three types. The tools are the annual tool, drilling tool, and ball mill tools.
Hello, Assalamualaikum. Now I would like to share about the methodology of this CAM project. This is all started with 3D modeling part using SolidWorks and then the file transfer into CATIA. We continue the stock creation surround the part and put an LZ system at the edge of the stock. Then we continue open a new file, editing a plane and insert an LZ system. After that, we go through an assembly operation of the plane system and the part with its stock using the LZ system that already be installed. Lastly, the part ready to go through machining operation such as roughing, pocketing, profile contouring, and isoparametric that I will be free later on. For roughing operation, we choose NMIL D20 as our cutting tool. We set up machining strategy, which is we set up 1.5 mm as our maximum cut. We set up the selection of geometries, which is we set up the part, stock, and the bottom of the stock. We adjust the micromanagement, which is we set up the plane of the cutting tool to define the pre-motion and post-motion toolpath. Next, for profile contouring operation, we chose NMD16 as our cutting tool. Our machining strategies for this operation, we adjusting the radial and axial strategy. For geometry selection, we select the bottom surface, the cutting element, limit 1 as start, and limit 2 for stop. For micromanagement, for this contouring process, we set up the plane of the cutting tool to define the pre-motion and post-motion toolpath, and then we set up the plane for return between level for approach and retract. Next, pocketing operation. For pocketing operation, we chose ball mill D6 as our cutting tool. For our machining strategy, we choose our helical as our toolpath style, and then we determine three geometries, which is the bottom surface, the cutting element, and the top surface. Then we proceed with micromanagement of this process. We set up a plane of the cutting tools to define the pre-motion and post-motion. We also set up for the return between levels for approach and retract. For the last operation for this project, which is isoparametric operation, we chose NMIL D3 as our cutting tool. The machining strategy for this operation, we choose 1 way as our toolpath and scallop height is 0.01 mm. We determine the two geometry selection, which is part and close bond as its guide. We adjusting the micromanagement for this process. We set up the plane for cutting tool to define the pre-motion and post-motion toolpath. Finally, we end up this project with turning the programming into G code and ready to set up for the machine. Next, result. For the left picture is final simulation result, and the right is final actual result.
Hi everyone, I'm Vino. Today I'm going to talk about discussion. In discussion, we are going to tell about errors and the problems, and also the solutions that we face and we develop in order to do the process of CAM in this subject. Okay. There are errors during the CAM process. Errors such as non-continuous interrupter, overmachining, uneven roughing surface, inability to machine couplers, and half stock is not required. So the solutions we developed: non-continuous surface contour. We adjusted the cam by readjusting the profile of the part design. So over machining occurred when roughing and profile contouring. This is because of safe plane issue and the cutting tool is too big. So we adjusted the size of the cutting tool, and we also defined a safe plane for the cutting tool to retract after machining the process. Uneven roughing surface. We adjust the cutting tool such as the angle size and the machining speeds. Inability to machine contours. There are some contours that are unmachinable. We are asked for guidance from lecturer. Some of the contours we have to ignore it as it was impossible to do in our current tool inventory, as the inventory does not have the cutting tool that we need. Rough stock not defined. So what we have to do was we have to define the rough stock at the rough stock section. The conclusion that we came after doing this project and after discussing everything. So reasonable technique and correct calling of the programs in CATIA CAM tools are most important and a core content. Even if the CAM procedure is correct, the lack of experience will still result in unsatisfactory process result. Therefore, CNC milling is not only greatly reduce the burden of the staff, but also improve the work efficiency and the part accuracy by eliminating the need for override. The main objective of this milling is to remove material from a workpiece to obtain a specific shape and improve surface finish. It is also important to properly secure a workpiece, as the workpiece can move and damage the cutting tool otherwise. So another factor is that excessive fits and cutting speeds are dangerous during milling. They can cause the workpiece to be damaged and also possibly break the machine. Thank you, that's all for me today.